Yep. So, hello everyone, and welcome to the session. Last week, we have discussed the theory of this specific project, which would capture the details from IoT sensors, and then it will predict the overall energy consumption or overall power consumption. In the due course, we have also spoken about a few deployment steps, right? And we discussed that these are a few things that our team has used. While we thought of using certain things to show you guys, you know, we figured out that we can basically use Flask, Python Flask, and then of course HTML and CSS to show you the entire deployment. And with respect to the database, we are sticking to SQL database. I know when we discussed last time, we have actually spoken about, well, one second, why is it? Yeah. So we have spoken about this specific architecture, which I'm going towards, Inflex database connector, and then we thought of showing you on Heroku, but because of certain technical challenges, we are sticking to Python Flask, HTML, CSS, and then we are, from database perspective, we'll be showing SQL. So from our side, our friend was actually worked on this project. We'll be sharing the screen. And Sendil, I would request you to make Madan the co-host as well. Yep. So Madan, I'm stopping the screen share. You might want to share your screen, and then I'm going to explain more. All right, so here we go. Can we open the database and first show the SQL database? So friends, will be showing you first the database. This is the database, okay? And for a data scientist, having knowledge about SQL database is kind of mandatory stuff, right? It is a prerequisite for anyone to become a successful data scientist. Having knowledge about SQL database is very important. It is imperative. And this is the data which we have along with timestamp. When I keep talking about these different variables, I request you, Madan, to hover your mouse on that particular, place. So timestamp is one column, first column. Then you have various other columns such as RCM, CWT, so on and so forth. From this, we are going to pull the data by connecting it to Python. So we will establish the connection between SQL database and Python. So can we now move to Python, please? And here, when it comes to Python, we are using Spider IDE, Integrated Development Environment. Okay, and if you see, there has to be code modularity, which has to be maintained each time you work on a project. For example, you have to sit down, think through what are the various things that you will do on the project and what are the various libraries which might be needed. So the first bunch of lines that you see is to load all the required packages. You select all of those and simply click on run. Yeah, that's how you click on run in Spider, and on the right side, lower pane, you see the console. We have already run all the lines of code and we have kept it handy, friends, because a few of the steps will consume more time. In the interest of time, we thought we are going to restrict the duration by running these lines of code and keeping it ready for you. Okay. Now, what we are doing is we are moving ahead with data collection. We are establishing the connection between the database and Python. For that, we will be running lines 16 until 19, right? So this will actually go establish the connection with your database, pull the data into Python, and store it as a data frame. If you can, my dear friend, hover your mouse onto the right side top, yeah, that's the data frame. We named it as beverage, and this is the data frame. Yep. Thank you so much. You can close it. Okay. And then you do some data understanding, beverage.shape will tell you how many rows and columns exist. Then you can run line number 23. Yeah. And in interviews, people will ask you on what is the dimension of your data. You have to say that dimension of my data is 18,000 by 11, meaning you have 18,000 rows. Hover your mouse onto the output, please. Output on the right side. Yeah, 18,000 rows and 11 columns. That is what it means. Now, when you say beverage.info, it will show you what are the various columns. Do you have any null values? And the last line in the output, if you see on the right side, it says memory usage is 1.4 MB. On the right side, my dear friend Madan will be hovering his mouse. Whenever I speak about anything, he will just highlight that portion. So 1.4 MB is the memory usage. Now, if you look at the next code modularity, we are talking about data cleansing. If you see line number 27, properly comments are written on what we are doing. For data collection in line number 11, we have written a comment called data collection. On similar lines on line number 27, we have written data cleansing. And then each and every step that you perform as part of data cleansing should be properly commented. So the lines of comment is very, very important. The number of lines of comment or comment lines that you give is very important. Each and every line has to have a very good explanation. Why? Will it not make it too complex or too cluttered? Not really. Because after you as data scientists build a model, once you deploy it, monitoring the model from there on, and then updating the model, upgrading the model, retraining the model whenever need be, is something which is done by a junior data scientist. So it should not become difficult. Life should not become difficult for a junior data scientist who is going to maintain your model. Senior data scientists usually build the models. Junior data scientists maintain it over a period of time. Next thing is you look at what are the various columns you have, and you get rid of irrelevant columns using your domain knowledge, right? So you should ensure that you use, no, that is already removed, right? You already have run that line. You already have run that line, my dear friend. If you don't want, yeah, you already run it. So that means that column got deleted. You dropped that column. Access equal to 1 means column. So once again, if you delete, it will throw an error saying that I don't find that particular column. Now we are looking at, do we have any null values? Already using beverage.info, that is line number 24, we could figure out that there are no null values. Line number 24, if you can hover, right? Already we have run that. But again, we are cross-checking in line number 33. Can you run line number 33? Yes. So if do you see there? in the output against each column, each variable, you see zeros. That means there are no missing values. Now, if there are any duplicate values, if you have any duplicate columns, you want to remove those. So you run line number 36 until 38. So there are no duplicates now because we have tried to find the duplicates and there are no duplicates. If there are duplicates, we will try to get rid of those. And this is also used to check the null values. So line number 32 and actually 41 are repetitive steps. Can you run line number 41, please? Again, the same thing has popped up. So the reason why we have incorporated these two lines is to tell you all that redundancy should be avoided. Now, having line number 32, 33, which is null values detection, once again repeating 40 and 41 will not make sense. So you also need to understand the bad practices which are followed. And we should not do this. Okay, it's a repetition, unnecessary code is not needed. Okay, anyways, just to explain you all that this is a bad practice, we have it there. Now, exploratory data analysis. Can you run line number 47, please? So here, entire data gets stored in this object called describe, wherein you have mean, standard deviation, right? Minimum value. When I keep talking about those, Madan, I request you to hover your mouse on that, please. Minimum value, 25th percentile, 50th percentile, 75th max value. All these values are calculated. Now, please, can you close? This is for the entire data set. If you just want mean from that, you run line number 50. And on the right side on the console, you see all the mean values of each and every variable, each and every feature. In that way, you can also calculate median. But just calculating is not sufficient, my dear friends. You have to look at what does each of that mean value explain you. What do I mean by, for example, if you look at the output, all plant, if you go to that, all plant, you see 358.155. What does that mean? On an average, your entire plant is consuming 358, maybe watts or kilowatts of electricity. Is it high or low according to industry standards? Is something that you need to do some research and make appropriate statements to your key stakeholders. Please, can you calculate median? I mean, quickly, if you look at this, and if you find that mean and median values are more or less the same, then good job. But if mean and median values are pretty different, that means you have outliers in your data set. Okay, so you have to do ideally proper descriptive analytics, not just run these lines of code and leave it just like that. For each and every mean value or median value, or line number 53, can you run it, please? 53, 54, right? And then 56, 58. Skewness is third moment, kurtosis is fourth moment. For each and every column, each and every feature, you have to write a description on what that value means. From business standpoint, you need to think through, do some research, and then write. These insights are extremely important, not just running these and then leaving it there. That is not something which will help you. What does that mean value mean? What does it or median value mean? What does variance or standard deviation value mean? If the skewness value is 6.77, what does that mean? If the kurtosis value is 207, what does that mean? You need to think through and write a description, detailed explanation about each of those. Yeah, next we have histogram, data visualization. Certain things you'll understand by looking at the graphs. So, yeah, there we go. Except for RCM, I don't see any other variable which is normally distributed. Everything else is probably uniformly distributed. They follow something called as uniform distribution, right? All plant is probably skewed. Okay. You have only two basically. And when you have distributions like this, right? Like if you look at all plant, my dear friends, you have only two bars. Okay. Here is where you have to break the bins. In histogram, you'll have bins, right? You split these bins into smaller bins instead of 350 to say 360. If that is a one bin, if you look at the x-axis, you break it down to 340 to 345, 346 to 350, so on and so forth, right? So you break it down into finer bins and then look at the distribution. Right? That is what usually is done if you have less bins. Yeah, please can you close it? And what will that tell you, right? So your data distributions explain you on what kind of techniques you might want to employ, because a lot of techniques expect your data to be normally distributed. Okay, if they are non-normal, you try to transform and see whether you can make them normal. But here everything else is uniformly distributed. So uniform distribution, usually you don't do any transformation. You use it as is, and you employ those machine learning techniques or algorithms which do not have any assumptions about the underlying data. A lot of algorithms have assumptions, statistical analytical models, that your underlying data should be normally distributed. But if you have uniform distribution, usually we don't do much. We just continue the analysis as is. But we employ techniques or algorithms which do not assume that underlying data are normally distributed. Yeah. Then can you run the box plot, please, to check outliers? So for each and every variable, especially for all plant, you see that there are quite a few outliers, right? So yeah, you can close this visualization and then select line number 69 until 75, please. So what here we are doing is we are trying to come up with that Q1 minus 1.5 times of interquartile range, Q3 plus 1.5 times of interquartile range, and we are looking at all the outliers there. And then wherever you have outliers, you want to select those, like in RCM column. If you look at line number 69, etc., you see RCM. That's the variable for which we are doing this analysis. Can you scroll down, please? Select line number 78 until 84. Yeah, please can you run it? So now what we are doing is we are trying to remove those outliers. Yeah, we are rerunning that. Yeah, those outliers are taken care of. They are removed now. Yeah, you can close this. Move on to line number 87, please. Here we have something called as profile report, which is kind of auto exploratory data analysis library. When we run it, automatically you can explore all the various things. Can you run it, please? I think in the previous module also we have run it and shown. Can you go to line number 96? Then, yeah, can you close the window? Sorry, this is just to get a layout, friends. Oh, it's taking a while. We are trying to close it. And these kind of things do happen, right? It depends completely on your, that cross mark is there, right? You can click on that. This happens with Spider, IDE, and Windows usually. So this is the pay plot. Anyways, you can move on. Move on, please. Then binarization also we have discussed. My dear friend, can you scroll down? Yes, please. Can you scroll down further? Further? Yeah. So we have done this. I mean, you can do correlation coefficient. You can then split the data in line number 122 to 124. You split the data into inputs and output. Then line number 126 until 130, you do min-max scaler because each of the variable has a different scale. You're trying to create, scaling. And once you do scaling, minimum value will become 0, max value will be equal to 1 for all the various columns. Then you move on to model building, line number 133. So we are trying to build line number 133, right? So there we are trying to, invoke decision tree classifier. And we are doing a train test split on inputs and output, wherein test data is 20%. If you see line number 136, 20% of the data is test and another 80% is training data set. Then can you scroll down? 141 until 152. So those are all the various hyperparameters. Okay, and hyperparameters are those options within an algorithm which you can change and tweak. So now can you select the line number 141 until 152? Yeah, you can run until that. Yep, sure. And build the model, yes. And once you build the model, you also try to use that model and predict on the test data. So you're building the model on training and you're trying to test it on the test data set. Well, just give me a minute, sorry. Okay. And once you do that, the predicted values would be stored in the object. Now you try to compare in line number 160, predicted values and actual values. And you're getting 0.92, means that is your accuracy on the test data set. Now, can you move ahead, please? And now we are trying to again fit the same model. And then we are trying to predict on the training data set. Remember one thing, friends, accuracy on the test and accuracy on train, if they are close to each other and high, it is called as a right fit model. But can we do any better? We don't know. So what we will do is we will test multiple hyperparameter options. So we are applying a technique called as grid search technique in line number 167. Right, so you see parameter underscore grid in line number 170. So here we're giving multiple options like maximum depth. We are trying out 2, 3, 4, 5, 6. These are hyperparameters. You can try out multiple things. So when you use those options, it will try out all the permutations, combinations, and then it will give you best result out. Yeah. Can you move on, please? Can you run whatever lines you feel valid and then move on? Okay. Next, if you look at line number 190, these lines of code already we have run, because usually grid search techniques take a lot of time because a lot of hyperparameters have to be experimented. In line number 190, the last hyperparameter or argument is n jobs equal to -1. That will ensure that all the processors on your computer get used. And there is a library in Python called as DASK, D-A-S-K, which will also help you perform parallel processing by making use of all the cores, C-O-R-E-S, all the cores that you have. You'll have dual core, quad core, etc. Nowadays, any decent laptop is having minimum 4 cores. So if you do sequentially, you'll make use of only 1 core. If you do parallel processing, all the 4 cores will be used. So it will be faster, effective utilization of your hardware. Yeah, can you move on, please? Then as part of line number 194, you find the best model. Out of all these combinations with different hyperparameters, it will choose the best hyperparameter setting, which is going to give you the best result out. Then you use that model to predict on the test data. Once again, look at, you don't just look at accuracy. That's a bad thing. You should not just look at accuracy. You also need to look at various other things. Will we be able to see the result if we run line number 197, Mother? Not sure. If yes, you can run. If no, we will ignore that. Okay. So line number 199 until 201, when you run it, you'll actually see alongside accuracy many other values such as what is a F1 score, right? So on and so forth, which is a better measure than accuracy. Because, of course, F1, again, I need to expend 2 times of precision into recall by precision plus recall. All that I'm not going to get into to that level. F1 ranges from 0 to 1, 1 being the best score. Okay, then it's not just one model. You need to try out multiple models. So we have also experimented random forest. Can you please select that? And those are the various hyperparameters. We ran a random forest also. And can you scroll down? And then we have used the model to predict on the test data. Then we compared the test accuracy. And then we also tested the model on the training data, and we looked at the training accuracy. Can you run line number 230 once again? Only that line. So this is giving us the test accuracy, which is 0.96. And the line above that, 0.95, is a training accuracy. So these are also high, close to each other. So you can conclude that this is even better model. But then if I change the maximum depth value in 237 to 2 or to 3 or to 4 or to 5 or to 6, what will happen? Right? So that is why you have those options. You have in line number 240 grid search cross validation technique. It will try out all those combinations and give you the best combination when you run line number 246. And you use that best model and you predict on the test data. And then we also tried out KNN model also. Can you just scroll down? Yeah, I mean, you need not show everything. I mean, we tried this model also, the same logic applied. And then we figured out that decision tree was the best model. Okay, that is what we figured out. Because it was also giving good explainability. When it comes to explainability, decision tree models are very good, right? Random forest has multiple decision trees, so to some extent explainability is impacted there. I mean, explainability is reduced. Okay, next what we do is we figure out on where to deploy. Of course, Heroku is something that we have used, but due to some code issues that wasn't running well because of version upgrades and all that, so we just ignored that part. But Python Flask is working well, just for you all to show. So when it comes to Python file, right? First of all, from all these models, you figure out which is the best model and you put it in model.py. Okay. And this is the entire model. We saved that model.py. Can you scroll down? After same thing, we have done the pre-processing, we split the data. Before splitting the data, we have done the scaling part. Then we build the right model. Then if you look at line number 52, 53, model.pkl, that is how we stored the model. Okay. Once you save the model on your computer, you can load the model from your computer, from your hard disk. And that is line number 56. Pickle.load will load, pickle.dump will save. Yes. Once that is done, you create a file called as index.html. Okay, this you of course need some knowledge, basic knowledge about HTML, etc. And majorly these things are a few things that you can copy, paste, and start reusing. There's nothing sacrosanct about what you see here, right? You need not worry about this. And after that, you go to something called as style.css. You just define how the style, background, etc., font size should look like. Then can you go to app.py, please? Now you launch your Python Flask by going to app.py. Now, can you show the next steps, please, my dear friend? So we go here, we copy the path where we have this model.pkl, model.py, etc., app.py. You just copy the file location. After you copy the file, can you show the file location once again, please, on which part you have copied? Yeah, that part. Yes. And then Control C. And then please go back. Yeah. In your navigator, whichever environment you are using, against that, you'll see that play symbol. Click on that. Click on Open Terminal. Okay. And then you paste it. Change your directory to that path. Now, can you click on Enter? Yeah. Now, when you say Python app.py, it opens the Python Flask application. I mean, it will give you the URL. It will start it and give you a URL. You can select this URL, right? And then go paste it here, enter. And then you have all these are the various inputs. What is the minimum value and max value is defined against each and every input. So you have to ensure that the inputs that you give fall in that range. So can you give some numbers quickly, randomly, which lie in that range? So okay. Now when you click on predict, it will go connect to your model, and it is predicting and displaying the results here. It's saying that the overall energy consumption is low. Okay, this is how you can visualize the predictions on your screen. This Python Flask application actually mocks your web application environment or mobile application environment, right? Or any of your business applications that you have. So this is how you build your model end to end. Of course, the monitoring and maintenance part, post-production, is something that is lacking in this project. Of course, like any project, there will be areas of improvement. So we intend to show you, the monitoring and maintenance aspects also moving forward, right? And also we have the schedule available with us for next week. All these are the live projects. So it is up to you on how you want to understand this, how you want to explore more areas, etc. Right? Next week on 27th, when we connect, every Friday from 6 to 7, we'll be having these sessions. Just in case we cannot complete in 6 to 7, the next week also we kind of extend that. So we have a project which is titled as Mental Health Well-being Analysis during pandemic times. That is the business problem, which is from life sciences healthcare. Okay, and we will see what is the technology stack that the team has used, and we'll once again look at end-to-end implementation. And this time when we see, it will be a different stack, technology stack, and we will affirmatively try to show you on Heroku, so that you also understand the model monitoring and maintenance aspect of it. Thank you so much, friends. And I'm pretty sure you all have liked this. You all have gained some interesting insight from this. So please ensure that You attend the future sessions also and make the best use of that. Do not forget to subscribe to our YouTube channel, and please do not forget to click on the bell icon. Just beside subscribe, there'll be a bell icon for notifications. That way, whatever sessions we conduct, you'll be notified. And one more thing, tomorrow from 7 to 7:30, CEO and founder of a company called as Aspecto, which is AI-based organization. The CEO would be speaking to you all, and he'll explain about the emerging trends in the space of data science AI. And he also has a few job opportunities, right? So please do not forget to attend that. You'll also get to see the job opportunities. Okay. Thank you all so much and have a great day. Thank you all, friends. Bye. Thank you everyone for coordinating the session. Thank you all, friends.